A projectile is any object or thing that experiences a single constant force due to gravity, like Newton's apple, or this cannonball. Because the force is constant, or close enough to be considered constant, and mass is always constant, well, almost always, acceleration due to gravity is constant, always acting downwards. Note that we always ignore air resistance in physics. Phew, but how do we calculate it? If you haven't guessed already, maths. More specifically, we use the Suvat equations of motion you should have learnt in year 11. Ta-da! Luckily for us, you can treat the vertical and horizontal directions independently with their accelerations and velocities and displacements separate. Why? Because any movement in x doesn't affect y, since they're exactly perpendicular. In fact, if you shoot a cannonball to the right at 20 meters per second from a height of 50 meters above the ground, it will fall at the same rate as the cannonball you simply drop at the same height and hit the ground after the same amount of time. Pretty neat. So, to calculate, for example, the time of flight or maximum height, you use Suvat on the y-axis, where a is just acceleration due to gravity, and u is the initial velocity in the vertical direction. You don't need to worry about x at all. The only thing that is the same for both directions is time. This is good, because that's how you can translate between the x and y directions if you want to. At maximum height, the vertical velocity is 0, so you can use v equals 0 in the formulas to find the time until max height, or the max height itself. If the projectile lands at the same height it was launched, the path is perfectly symmetrical. So, the flight time until max height is exactly half of the full flight time. That's projectile motion.